So, hi everyone. My name is Michael. Michael Duarte. I work in YouTube Premium in Google. I'm currently based here in San Francisco. Today, I'm going to give you a talk or a review session about inheritance and polymorphism. So, this is intended to be very short, and I'm going to jump into examples that we can discuss later. Feel free to unmute yourself or ask questions in the chats, whatever is easier for you. And again, I'm going to leave some minutes at the end in case you have any questions related to these topics or any questions in general for myself. All right, let's start. So inheritance. Inheritance is an object-oriented programming mechanism which allows classes to inherit fields and methods or functions of other classes. So we define to these classes are inheriting subclasses or also child or derived classes. And the ones that are being the parents are superclasses or base classes. So in this example here, you can see the shape is a class that is parent of circle, rectangle, and triangle. And at the same time, rectangle, even though there is a child of shape, is also the parent of square. This is just for illustration. My reasoning was the square is pretty much a rectangle, but all the sides are the same. So it's like an edge case of a rectangle. So what is the use of inheritance, you may say? So inheritance allows us to reuse code from the parent class into other subclasses without having to copy and paste. For example, we can say the shapes have a name. They have area, they have perimeter. So if we define that in the base class, we don't have to copy all these functions or all these attributes into the subclasses. We just inherit from the parent class, and then automatically we have all these fields accessible to us. For example, as I said before, you have the name, you have the area and the perimeter. So we wouldn't have to define them in the subclasses anymore. So that's it. That's pretty much inheritance. I'm going to jump into an example later, but the only thing that you have to remember is when you feel like you don't want to copy the same thing over and over to different classes, and they can be like, they can be thought of these subclasses, even though they're more specialized, they go back into the same class. They can think of being the same. For example, you can think of a circle being a shape, a rectangle is a shape, and a square is a shape. So all these is A or is R relationships, that tells you a little bit of inheritance. You can think of a circle as a shape. So whenever a function is expecting a shape, you can pass either of these subclasses, and the code is supposed to be working as expected. Why? Because all of the functions or methods that you're expecting to call on shape, they're accessible through the subclasses. So you don't have, even though that you could have redefined the get area and get perimeter, get name in the subclasses, but even if you didn't, you're gonna get them automatically by inheriting from the parent. Are there any questions there? If not, I'm gonna jump into polymorphism, which is very similar, but there's a small twist. So polymorphism, it comes from two words, poly, which means multiple, and morph, which means shapes or forms. So the fun thing about this polymorphism is that the subclasses, as we said before, they inherit the definitions of the functions and the attributes of the parent, but also we can think of these subclasses of being more specialized, so they can change the way that the functions or the methods are being defined. So shape can define a get name, get area, get perimeter, and then circle can define it separately. Rectangle can define it differently, and triangle can be different. So this is what we mean by polymorphism. Even though that you're inheriting these functions or these methods, and they're accessible by anyone who calls these references or these objects, they have the freedom of redefining them, changing what is going to be the definition. And again, if we go if we go back to the example, if there's a function that accepts a shape, it knows that it can call get name, get area, and get perimeter. But the way that you calculate an area for a circle is very different to the way you calculate for a rectangle. Just going more into the details, for circles is pi times radius squared. And for rectangle, the way you calculate the area is base times height. So you can think that there are different properties there that shape doesn't know of, but these subclasses might define them by themselves. So if we go by the UML representation of this, if we define these classes, you can see the shape is defining this attribute, which is the name. And it's also specifying the get area, get parameter, get name. These are the methods that are going to be inherited by all the subclasses. You can see here that the subclasses, they keep the same references to the one they inherited from the parent, and they have the same color just for illustration. But also they have the freedom to define their own. For example, circle has radius, triangle has 3 different sides, rectangle has the base and the height, and square, since it's inherited from rectangle, it also inherits the get base, and get height, but also is defining its side length. Okay, so if we jump here quickly into this code that I have prepared, as you can see, I'm defining this shape class. It has a constructor which receives a name, and is defining these 2 functions that I have talked about before, these 3 functions. One is the get area, get parameter, and get name. As you can see, since this shape doesn't have any information about its size or its shape more defined, it's the only thing that it's doing is defining this default get area and get parameters, which return 0. But it's also printing this message like area is not defined, parameter is not defined. So what we're expecting is that the subclass is going to be redefining this by polymorphism. And then we're going to be able to calculate the area and the perimeter by the shape. So if I go to circle here, you can see the circle, the only thing that it's doing is calling its inheriting shape. It's calling its constructor with the name circle, and it's defining its own attribute called radius. If we go to main, you're going to see that I'm creating a list of shapes. And the first one that I'm creating is a circle with a radius of 10. And then I'm printing all the information that I have defined for the shapes. Sorry, I forgot to mention, but shape has this function called print all. And what it's doing, it's printing its name, printing the whatever value or code is being in get area, and also the same thing for get parameter. So when we execute main, this is the first thing that we get. We see that the area is not defined, and it returns a 0.0, and same thing for the perimeter. So as you can see, even though that I didn't define the area or the perimeter here in the circle, by default, it's getting this inherited by shape, and we're executing this code here. Now, we want circle to have its area and its perimeter. So the way to do that is, let me just copy paste this. So as we had said before, the area for a circle is pi times radius square, or radius times radius. The perimeter is pi times radius times 2. And also, as you can see, I'm overriding these default methods. So whatever the parent had defined for these same names, I'm redefining them. And whenever a circle is being called to these methods, we're going to be executing the ones from circle. If they were not defined, as we see earlier, we would be calling the ones from the parent. And also, as you can see here in print all, which is also defined in shape, we're calling the parent's definition first, because we want to call whatever was defined by the parent, but also I want to add circle's touch. Since circle has also the radius, I want to also print this attribute, which is defined here when we construct it. And also, just for simplicity, I added a get radius function. So that way, whenever we are dealing with a circle, we can just call get radius and we're gonna get it. So let's see what happens if we run this code. Oops, so radius is not being printed. Let me see why. Oh, maybe I didn't save it. No, it's there. Okay. So radius. It's not being printed by some reason. Okay, let's go back.
Where are you calling it from?
What was that?
Where are you calling it from? Is it in, what do you have in main?
I'm calling from main, and then for all shapes, I'm calling print all.
Okay.
So far we have only defined the circle.
Right.
Okay, I might find out why this is happening earlier, but let's move on to rectangle. Rectangle, same thing as the circle, it's inherited from shape. And as I had explained before, square is inherited from rectangle. The main difference is that rectangle is receiving two attributes, which is the base and the height. And for square, we only need one because it's the base and the height is the same as this side. So we're calling the parent constructor with this parameter we received, and then we're defining our own. This is completely optional. We could have just used base or height, but when we want to refer to squares, we don't want to refer to each side by base or height. We just call it, give me the side length. So that's why I decided to just define this attribute here in square. And also, since the parent is setting the name to rectangle, I'm overriding it to be square. So let's see what happens when I add this to my list of shapes and execute this. So as you can see, oh, there's the radius now. I don't know what happened. Let me remove this print. There we go. So as you can see, radius is green because I just wanted to make it more obvious that this is specific to circle. While the white text, area and perimeter, this is printed by the base class. So yeah, let's go back to rectangle. Rectangle hasn't defined anything, same for square. So they're having this problem in which they're just inheriting from the parent, but they're not overriding. They're not using polymorphism to define their attributes more specifically. So if I just copy this code, go back to rectangle. Sorry for making this very fast. I'm just copying and pasting here, but pretty much what I'm doing is using these attributes that I defined, and I'm redefining get area, get perimeter as a circle. I'm calling the parent when calling printing all. I'm going to call the parent so we can print the defaults, and also I'm adding the base and I'm adding the height. So let's see what happens now. As you can see here, base and height are specific to the rectangle, so I paint them yellow or orange. And for square, even though that we're inheriting from rectangle, when calling print all, what I'm doing is skipping the rectangle print all. I don't want to call my parent. I want to call my grandparent. Since I don't care much about the base and height that is being printed here, I went straight to my grandparent, like, hey, grandparent, print whatever you had defined for print all. And when you're done, I'm going to be printing my own, which is, I'm just going to tell you this side. I don't know why sometimes it's skipping this. Oh, there we go. So as you can see here for square, it's just defining the side, which is the same. And since we're skipping the parent, we're not printing the base and the height. Just for illustration, we could have just called the parent instead of the grandparent. And then we see that when we call square print all, it's first calling the grandparent. Well, it's calling the parent, sorry. And the parent is calling the grandparent first. That's why you see this white, then this yellow from rectangle, and then this red from square. But since I don't care about the base and the height, because I want this to be a little bit invisible for the colors, I just go straight to the grandparent, and there we go. Lastly, very similar is for triangles. Triangles has three sides, but there's this special case that there's a triangle that has the same sides length. We call the equilateral triangle. So we just receive one side, and we pass this side to the parent's constructor 3 different times, one for each side. If we go to main, let me just uncomment this. We haven't defined any get area, get perimeter, so we're gonna get the same errors as before, and you can see them here. Let me just copy and paste really fast the override for triangles. So I just want to make this very, very obvious. Here, we're just inheriting. Even though that we're defining our own attributes, we're not overriding anything that the parent has defined. So this is just a pure example of inheritance. But now the change that I'm going to make, that's more polymorphism because we're redefining what we're inheriting from the parent. So there we go. We redefined get area, get perimeter, print alt, and also we added these getters for each side. And for equilateral, just for fun, even though that we could have reused the same code, there's a different way to calculate the area for triangles that have the same side lengths, which is this one. Side times square root of 3 divided by 4. There's a long way how they came up with this function we're not going to get into. It's just to see that even though that it's pretty much the same, there are different ways to calculate the area. And just for fun, I just created a different subclass. So I save this and run it. And you can see here that in white, it's being printed by the shape. And then the triangle is printing these 3 sides as attributes, as blue. And it's the same here. As you can see, this triangle has the same area and same perimeter as the equilateral triangle. The reason is that they have the same side lengths. So even though the function get area definition is different, they give you the same result. So just for going back here, the shapes that are created is 1 circle, 2 rectangles, one of them is a square, and 4 triangles. One of them is an equilateral triangle. And then everything that I'm doing is just calling print all, just to get all this information from the shapes. And this could have been in its own function. And since I'm expecting a class that is a shape or inherits a shape, it could have been safe to pass any of these subshapes or subclasses of shape, because we know for sure that they have defined that print all. And if they didn't, they are inheriting from the parent. So this is the final output. You can see circle with its own radius, rectangle with basic height, a square with the side, and the triangle with the 3 sides. Are there any questions? Okay. So if there's
Michael, if there are no questions, I'll ask a question.
Go for it.
So in the diagram that you showed in the presentation, the attributes for the fields, right, appear to not be inherited, so to speak. We explicitly show the methods getting inherited. And so the question then is, does the name property, if we were trying to access the name property in circle or in rectangle, would that still be there?
Yes. So as you can see here, I put a small minus sign and plus sign. What I mean by this is that I expect name to be private to shape. So even though that these classes are inheriting from shape, they don't have access to the private members. This one that has this plus sign, I expect them to be public, and subclasses inherit the public functions. In Python, though, we can access these ones here because there's no such thing as private or public. What we do is just by definition, we have these underscores, which means that they're specific to the class and maybe you shouldn't be accessing them. But I'm breaking that rule in the subclasses of the grandchilds. For example, if I go to rectangle, you can see here that I'm accessing the shape.
I think you wanted to switch tabs on what you're presenting.
Oh, I'm sorry. Yes. Yeah. Yeah. Sorry for that. So yeah, what I mean is that you have the double underscore here name, which means that this is specific for shape. This attribute gets, I think it's called demangled or detangled. So this is going to be specific to this class. And it's expected to just be accessed here. But I'm breaking this rule a little bit in the grandchild classes because I want to change the name. I could have avoided this by just creating a setter in the shape, but I didn't want to expose that for other outside of the shape class to modify the name. So I just break this rule a little bit and I say like, all right, from the class shape, I know that it has like this private name and I want to override it to square. To be honest, my personal languages are C++ and Java, and they're very specific when you're defining something private and you cannot access it in any subclass. And when it's public, you can access them. In Python, this is what I found in this week when I was writing these examples. So yeah, I was able to override this that is expected to be private. But yeah, it changes by language and language. I don't know if you want to add something else, you think? You are more experienced with Python.
Yeah, I mean, I think you mostly covered it. Just like it comes down to designing it with including a set set name function, but yeah, you said the private aspect of it, or you could get around it by calling the shape superclass instead of the rectangle superclass, and then you could set the name directly.
Exactly.
But yeah, we didn't go over it in class at this kind of workaround, so to speak. I know we told you all that when you do double underscore, it's really private, and for the most part, it really is. You can't access the attributes directly. You can't do dot name or dot underscore underscore name. But yeah, there's this kind of, you have to really work. You have to try. You have to really specifically want to go get around that rule by doing it the way Michael's doing it here in order to access it. And so it's kind of a little, you could think of it as a backdoor, kind of, in that it's a small hole that you can kind of peek through if you need to, but generally shouldn't.
Exactly. You have to be intending to break the rules, but you can do it.
Yeah.
Okay, let's go back to the presentation here. So if there are no more questions, thanks Yufeng for making that question about the inheritance of the fields. In Python, you can think of fields also being inherited. I just didn't specify them here in case you want to implement this in a different language. You can see a little bit more about what I'm expecting with this minus and plus sign. This is just for visibility. Also here in rectangle, since these are expected to be private, that's why I didn't put them on square. But as you can see, since these are private and the get base and get height, these are visible here. And if there are no more questions, I have another example we can jump to, and then I'll think to go. Yes,
I think
Yamil?
Yamil has a question. He used the hand raising feature.
Yeah. Sorry to interrupt. Silly kind of question, right? But when you, well, of course, you start with shape. You define shape, and you use it as your main class, as your super class, kind of like the grandparent of everything. When you define the other functions, like I'll take for example get radius from circle. You're gonna define it right there in the tab with circle, right? You're just gonna define it right there.
Yep.
Yeah, sorry, kind of a silly question. Just wanted to make sure of that.
Yeah, so get radius, you can see that it's only here in circle. Why? Because this is the only class that is defining its radius. So what would happen here if I call shape.print all, but I also call shape get radius? What do you guys think it's gonna happen?
I'm thinking it might cause an error, but print all.
Yeah, so
It'll print it out again. It'll print it out again.
Okay,
just radius.
Just the radius. But I'm calling this for all the shapes. I think for circle, it's gonna print it again. But what do you think is gonna happen for these rectangles and these triangles?
They're gonna. Sorry, come again.
So rectangle and triangle, they don't have this function defined. So there's gonna be an error. Let's see. Okay, here we go. So as you can see, for circle, we print everything. We call the print all, and then we call the radius. I'm calling in the main. Yeah. So rectangle, when I'm calling with get radius, it says like, I don't know what you mean. Like this is not defining me and this is not defining shape in my parent. So I'm just gonna throw an error, and that's the error we're getting here. Like, hey, rectangle object doesn't have an attribute called get radius. We didn't get this error for circle because this is defining circle. In other languages, you would have a compiling error. So it would have been, even though that it's expecting shape, it will be telling you like, hey, shapes doesn't have a get radius, so you cannot call this. Python, it's not compiled, it's interpreted. So you don't get an error when you execute. Only when you go into this line and it's invalid, it's when you get this error. But that's a good question.
So basically what you mean by that is that in other languages that compile, the program won't run, but in Python it will run until it is allowed to. Basically, is what you meant to say.
That is correct. So putting it into comparison, C++ and Java, these languages, they are compiled. So in order for you to create the program that you're going to be executing, you have to do one step before, which is compiling. And then there's a lot of a lot of analyzers for syntax, for the meaning that you're trying to give it. It's a way more deeper topic. But compiling, it's gonna give you any errors. It's gonna give you any errors when you try to compile. For example, if there's a function that expects a shape, and then you're calling a method that is not defined by shape, it's gonna tell you like, hey, I cannot do this because this is not defined in shape. So even though that all the subclasses have this attribute, since I'm referring to shape as the interface is just what the compilers know that I can call. It'll be like, I cannot do this because shape doesn't have get radius. In Python and JavaScript, these are interpreted. So you only get the error once that you face the error. So for circle, it worked perfectly. For rectangle, the first rectangle, it doesn't have radius, and that's when you crash.
Yeah, because now I think I'm getting it. Basically, what happens is that in main you're calling for everything and the functions to be put out, and if you call radius, it's going to start looking for radius in the other shapes, and of course, radius is only specific to circle. Okay, exactly. I get it now.
Yeah, and you can think of, since this is interpreted, when it finds a rectangle get radius, the first thing it's gonna do is like, all right, rectangle, do you have this function called get radius? And it's gonna say nope. Well, I inherit shape, so check up in shapes, and shape's gonna be like, nope, I don't have get radius, and that's when it crashes. So you can think of going up in the ladder of inheritance to see where you can find this function. But since neither rectangle or shape has get radius, that's when we get the error. But right. Yeah, that's a good question.
Yeah, thank you so much.
You're welcome. Okay, so we have 15 more minutes for presentation, but I'm gonna leave a few minutes afterwards in case there are more questions, or also we can talk about anything related to working at Google or any questions that you might have. So feel free to ask any questions. So for the next example, this is more about bank accounts. So you know that when you go to the bank and you're planning on opening an account, there are different type of accounts that you can open. Checking, for example, is expected for you to where your boss is gonna pay you for your payment when you're working. Also, you can use this for paying. You can use this for withdrawing. You can transfer to a different account, and of course, you can get the name of the account. For savings, in the other hand, these are expected for you to put money into, but you cannot use this for paying or for withdrawing money. You have to transfer that money to a different account and then spend it. For credit, this money is money that you don't own. It's money owned by the bank. So you cannot withdraw money, but you can use it to pay. So when you go to a restaurant, you're paying for a phone, you can just pay with credit, but you cannot go to an ATM and try to withdraw money because that money is not yours. Nowadays, there are exceptions. You can go to the best credit card and then they're gonna give you money, but then you have to pay more. Just for simplicity, let's think that for credit, you cannot withdraw money, but you can pay. For savings, you cannot pay and you cannot withdraw money. For checking, you can do anything. So what I did here is all these checking, savings, and credit cards or accounts are inheriting from account. The only reason I did this is because most of them, they share the same things. They share a name, they share a way to deposit money, withdraw money, pay, make transfers, and also there are some attributes there. The name, the balance, if this account is blocked, or if you can withdraw or not. This is for inheritance. You can see that I'm just inheriting what is defined in accounts. But if we see the polymorphism side, we can see that we can override what the parent is doing. For example, savings is this attribute code here is blocked. It's blocking me for withdrawing and for making payments. But for credit, I just override the can withdraw to false. That way I cannot withdraw. And also savings, you can accrue interest. That's the most fun part about having a savings account. Each month, the bank is gonna give you money for the amount that you have in your savings account. Is gonna give you some interest. And then this is the only account that has accrued interest. We could have done something similar for credit. So if you don't pay what you owe, you're gonna pay interest on that. but for simplicity, let's just think that savings account is going to give you money for 1 month for some interest rate. And I'm just going to bring that code here. Sorry, is there any questions about the UML, the Unified Modeling Language representation here? If not, I'm jumping into the code. Oops, let me clear this. This is not safe. Okay. What did I do? There we go. So this is the main class. This is the account class. So as you can see in the constructor, it defines the attributes that I showed you in the diagram before. It exposes some getters: get name, get available balance, get balance, deposit, withdraw, transfer to, pay. As you can see, these functions are very complex, and I would hate to copy and paste this into checking account, credit account, savings account. So that's the reason why I decided to put this in a base class. That way I don't have to repeat this code over and over and just make some tweaks here and there. So I'll just go really fast into this. Get available balance it refers to the amount available for you to spend or withdraw, compared to get balance, which this change depending on the type of account you're in. For example, if you have a checking account, the balance is the money that you have and that you own. When you go to the credit card and you check your balance, it's pretty much the money that you owe. So if you spend $500 in your credit card, your balance is going to be $500. It's not the money that you have to spend, but it's the money that you owe. So depending on the type of account that you have, get balance has a different meaning. That's why I have this available balance, which is the amount that you have to spend, and this one that is the amount that it changes depending on the account. By default, I said that all the accounts balances are going to be whatever is defining get available balance. Deposits is just making an amount available in your account, so you just add it to your balance. Withdrawing, we have all this logic here saying if this account is not blocked for spending and you can withdraw, if you cannot do this, sorry, we're going to print this message and then we're going to return. Sorry. And if the amount that you want to withdraw is less than the amount that you have available, then you're going to remove this balance, this amount from your balance, and then you're going to return true because this was successful. Same thing for transfers. Transfers is like withdrawals, but instead of getting cash, you put it into a different account. So you make a deposit to the account that you receive as a parameter for the amount that you're passing as parameter to. The only restriction is that the amount has to be less than whatever you have available in your account. And I'll just skip the details for it's pretty much the same thing for payments. For payments is just when you go to a restaurant where that you use your credit card directly, that's kind of a payment compared to going to an ATM that you can withdraw money. And then we have these getters here for can withdraw and is blocked for spending. This we're using in this base class just for doing some checks when you can withdraw and when you cannot. For checking, we can see that the only thing that it's doing is defining its name and is defining its initial amount for the balance. It's doing nothing else. It's like the vanilla flavor. You get everything from the parent and you don't have to change anything. This is purely inheritance. There's no polymorphism here other than changing the names. But since this is in the constructor, this is not polymorphism. This is just inheritance. On the other hand, if we go to the credit card, since credit cards are more restricted, these accounts can be used for paying, but not for withdrawing. So we initiate with the can withdraw parameter as false, and we don't change it throughout, so it's always false. In here, the get balance, it's different. The get balance for credit cards is the amount you owe to the bank. So this is the balance that you have spent. And the way we calculate it is a negative value, that is your initial credit. For example, we initiate the credit cards by default for 5,000, and then you subtract the available balance. So whatever you have spent You want to calculate the difference for what you started and whatever you have available. So that's going to give you the amount of money you owe. Deposits for credit cards, you cannot deposit more of the money that you owe. So you always want to check how much you owe, and the amount has to be below what you owe. If not, it won't let you. Say like, nope, you cannot deposit more money than it's owed, and it's going to return false. But if the amount is below the balance, then we can deposit into this account the amount that we specified. And for transfers, we don't allow transfers. For example, you cannot say, I'm going to add money to my savings account. That would be cheating, because this money you cannot withdraw, and you're expecting this money to create interest in the savings account. So we said, nope, we don't allow you to transfer money to a different account from the credit account. So the only thing that it's doing, it's overriding the accounts transferred to, and it's adding its own flavor. And to just disabling it, it returns false, and it prints an error. For savings account, it's the same thing as a checking account, but it's blocked for spending. So you cannot even withdraw, you cannot pay. And also the cool thing about the savings account is that you can accrue interest. For example, each month, we can call this function. It's going to generate interest based on the current balance that you have times the interest rate that you have, and then you just have a deposit for that interest. So that's pretty much how I define my classes. If there are any questions, I can always go back to them. But for now, let's go to the main. So let's just imagine that I went to the bank and I opened 3 accounts. I opened the checking, savings, and credits. The checking initial amount is $100. Savings account is $1,000. And they open a line of credit for me for $500. I'll just comment this out for now and see what's happening. So as you can see here, my header says that I just opened the accounts. My checking balance is 100, saving is 1,000. And I also get this message: this savings account cannot be used for spending and cannot be used for withdrawing cash. Then I go to credit, and my available balance is 500, but the balance here is the money I owe is 0. So everything is good. And I get this message too: credit account cannot be used for withdrawing cash. Let me really quick read this message that I have here. So Hector is asking, going back to the get balance function, putting that minus sign in the front of those parentheses of the return for get balance will make the value get negative. You don't need to put the minus times. Yes. So that's just a shortcut for doing exactly the same thing. You can think of, let me just open the credit account. Yes, so Hector is referring to this minus sign here. This is exactly the same as having -1 times here. But yeah, it's just a shortcut for doing the same thing. Yeah. Thanks for that question. So yes, this is what happened when I went to the bank. I opened 3 accounts. You can see the balances. You can see the 3s that I'm giving here to credit. Balance is 0 because I don't owe any money, but I also have this available balance that I can spend. Now, let's say that I go to the store and I try to buy a new phone. First, I try to buy the phone with my savings account, but as you can see here, that's not possible. And if that's not possible, I want to pay with the credit. Let's see what happens. So my header here is saying trying to buy a new phone. And it says that savings is disabled for making payments. So, okay, since savings cannot pay for this phone price, I fall back to the credit. And I do credit.pay phone price. Phone price is $460. And yeah, this is the message that I get. I paid $460 from credit. And then I print this statement here: made payment with credit card. Item is worth $460. Cool. Now I print again my balances. You can see checking is untouched, savings is untouched. I tried to pay with it, but it's disabled, so everything is untouched. But for credit, the available balance is 40 because I have already spent $460. And you can see here balance is red because it's negative. I owe to the bank for $160. So that sucks, but at least I got a new phone, right? So let's fast forward to another month. Let's say that I didn't make any other payment. I just wanted this credit card to pay for a new phone. Oops. So let's say that a month has passed. What happens in a month? So a month later, the employer deposited, the savings accounts generated interest, and since I have a new phone, I have to pay the phone bill. So you can see all the transactions that I did here. My boss deposited $1,000 in my checkings account. Since sorry, I didn't show you what the interest rate was for my savings account. Here, my interest was 2.5%. So for $1,000 that I had in 1 month, I generated $25 in profits, and that's automatically deposited into my savings account. So as you can see before, my balance for checking was 100, but with the deposit is 1,100. My balance for savings was 1,000, but with the interest is 1,025. And I paid a bill for $40. That's what I pay for my phone bill. So I used to have $40 available for withdrawing for using in my credit, but now since I spent it, I have $0, and I owe to the bank $500. So since I have money now, what I'm going to do is I'm going to pay my debts. So what I'm doing is transferring money from my checkings account. I put in $300 into my credit, and from my savings, I'm moving $25, just the interest that I accrue, into my credit. Let's see what happens. As you can see here, my new balance for checking is 800, sorry, because I removed 300 to move it to the credit. And savings is back to 1,000 because I removed the one that I had accrued, the $25, into the credit. And you can see now that the credit has a available balance of 225, which is the adding of these two. And my balance, the money that I owe to the bank, is 175 from the 500 I used to have before. So as you can see here, all of the heavy lifting, all of the logic for the accounts is just in this accounts base class. And then I'm just making these other classes, the credit account, just more specialized, like just defining like, all right, your whole work is going to be this small work. For anything else that you might need, just refer to your parent class. So as you can see, savings account and checkings account, they're pretty small because they're pretty much using the same thing as the account. And yeah, that's it for the example. Are there any questions? Also, if you want, I can share the slides, and the slides have references to these codes so you can play with them, and I can share in Discord later.
We would appreciate it. It's really interesting, and we would like to see how we can work with it. So, yeah.
Cool. Thanks, Emil.
Great. Thanks so much, Michael. These were really good examples. Really enjoying the use of colors in the terminal. Haven't played around with that this semester at all. So I'll be looking forward to digging through your code a little bit to see how you did that. Manuel has a question about why the balance increased from 460 to 500. I think that's just because you had a $40 phone bill.
Exactly. So yeah, Manuela, the thing is that my balance was 460. That's the money that I owed. But when a month passed, I was paying for my phone bill, and my phone bill was $40. So I spent the last $40 that I had, and now my balance, the money that I owe, is $500. And I have no more available balance in my credit card. So the $40 there came from the phone bill that I paid. If we go to the code, so here, fast forward a month. The phone bill was $40, and that's why it changed. And regarding the colors, I found colors be really useful when you are trying to see things while debugging. For example, you can see here in the previous example for shapes, you can see that each color referred to a certain class.
Yeah.
So you can see, you can see that, okay, when it's white, that's a vanilla flavor, that's the parent. For the subclasses, I use different colors. So that way you can see what's going on more effectively. And for that, you can see the only thing that I'm defining. So terminal, all the terminals nowadays, they have support for colors. The only thing that you have to print is these like weird characters. These are like Unicodes that terminal knows what they mean. So this is the header that I'm using for purple. OK, green is what I'm using for green. Fail is what I'm using for red. And there was orange that is the warning. So the way that it works is, for example, let's go back to my main. When I want to print a header, I start with terminal colors header. I print the message that I want. And it's very important for you to finish the color. Otherwise, you're going to keep this throughout the terminal. So everything that you print is going to be keeping this same format that you gave before. So it's always important for you to print the NC. The NC means like whatever I had told you to print for colors or format, remove that.
Reminds me of what you have to do at the end of C++ prints, right? When you have where's it C, where you have to do the end, the start and the end, right?
Yeah.
But I guess looking at that, one thought would be in terms of if you wanted to save yourself having to type end color every time or end C, you could write like a custom print statement that's like print C or something, print color, and that way you only have to pass in the header or the starting color, and it would just automatically insert the end color for you.
That would be the ideal way of doing it. That way you don't have to remember and most likely forget to call tc.nc. Yeah. So yeah, as you said, it would be better to just have a function receiving the color or the format you want and the string you want to print, and then that function taking care of tc.nc. Yeah,
it just gets sandwiched. Your text needs to be sandwiched with those two special Unicode values.
That's right. Are there any other questions? If not, well, I'm going to leave a few minutes, 10 more minutes, if there are any more questions outside of these topics. If not, that's what's it for me. And thank you for your attention.
Thanks so much, Michael. This was great.
Stop recording now.